Hello everyone. There are three blocks in this system. There are two pulleys. One pulley is movable pulley, another pulley is fixed pulley. We have to find out the tension in the strings and the acceleration of the blocks. Let's do that. Now, let's say the tension in this string which is connected to M1 is T. So here there will be T tension, here there will be T tension, here also T tension, here also T tension is there. Now, here the tension is T dash and here the tension is also T dash. It is not same as T, you can see, because this is a different string, right? So if the string is different, the tension has to be different. Okay. Now this is mass M2. Okay. Let's find out the accelerations. Okay. Suppose this particular pulley is gone in this direction by x amount, then what will happen? If this particular pulley has gone this way by x amount, this M3 mass will go down by x amount, because the block will go by x amount and M3 will also go by x amount because it is attached to the M2 block. So it is going by x amount. Now here the string is fixed. So once it has gone by x, this string has to move forward by 2x because this is movable. Okay. So this has to move by 2x amount in this direction. So if the acceleration of mass m3 is a, then the acceleration of mass m2 is a, but the mass m1 it is 2a. Let's draw the free body diagram of mass m1. So if I draw the free body diagram of mass m1 like this, then there is a tension T in this direction and there is no other force. So I will write T is equal to m1 times 2a. This is my first equation. Now let's write the equation for mass m3. Okay, so I will use different color for that. Mass m3. This is mass m3. Upward force is T dash. Downward force is m3 times g. And you have m3g minus T dash is equal to m3 times a as your second equation. Because it is going down, right? M3g is greater than T dash. Now let's write the FBD for M2 mass. For M2 mass, we have a force towards right direction of T dash, force towards right direction of T dash, and towards left there is a certain force F. We don't know because of this triangular shaped thing over here. There is a force F dash. We don't know F. We will say so. T dash minus F will be M2A. T dash minus F is equal to M2 times A. This is the third equation. Now you look at this movable pulley over here. Now if M2 is being pulled by F force, this pulley will also be pulled by F force because of Newton's third law. So the pulley will be looking like this, the free body diagram of pulley. This is, these two are T, okay, and there is F force over here. Since the pulley is massless, we can write this equation directly. F is equal to 2t. Since mass times acceleration will be 0, F will be equal to 2t. So we got this equation over here. So F is equal to 2t. So we have t dash minus 2t is equal to m2a as our fourth equation. Okay, so let's write the acceleration and the tensions. So if I add this, if I multiply this first equation by 2, what I will get? If I multiply this first equation by 2, I will get 2t is equal to 4m1a as my new equation. 2t is equal to 4m1a. Okay, now let's add these um, equations, the second one, third one, and the fifth one. If I add this, I will rewrite this m3g minus t dash equation first. Let me do that. M3g minus t dash is equal to m3a. Let's call it the second equation, so sixth equation. So let me add all these equations. If I add this, t dash and t dash will get cancelled, 2t and 2t will get cancelled. We will have m3g towards left is equal to 4m1 plus m2 plus m3 times a. So the acceleration will become m3g upon 4m1 plus m2 plus m3. This is the acceleration A. Okay, that acceleration is of this block m3 and m2, and if you multiply it by 2 times you will get m1 acceleration, right? So if you put this value of A in these equations, you will get the tension. You can put the value of acceleration in this, you will get tension T, and to get the tension T dash, what you will do, you have to put it in this equation because T is already known to you, right? Okay.